I'm going to stand a bit near you so that the microphone picks
Good
me up as well.
Yeah.
Hello everyone. Hello. Thanks for coming along and, I don't know, I think braving the weather outside. It was nice when I got here, but that was many hours ago. Yeah, welcome to the DoES Salon, and welcome to DoES Liverpool. If you want to know anything about the co-working space or the makerspace, then feel free to give me a shout, and we can show you around. We are streaming on the internet, I hope. It seems to be working okay. We've been streaming a test card for the last 10-15 minutes, so now I think we're streaming video and audio. I don't know if there's anybody online or not. I guess I'll find out. And you'll be able to watch it back later if you want to. We're not expecting any fire alarms, so if there is a fire alarm, then follow us to the fire exits are down the stairs and out the front door, or there's another one through the main space and out that other way. Toilets, similarly, there are some through the way through there, but I don't think I've got a fob here for you to use them, or there's some at the bottom of the stairs. You don't need any access to get to the bottom of the stairs. So this evening we are with the pleasure of Luke telling us about the work that he's been doing into fuel cells, his research, and I don't know what else, but that's why we've gone along to talk about stuff. One other little bit of housekeeping, we aren't going to have a salon next month because it's a bit too close to Christmas. So we'll let you all go off and have your Christmas parties, what have you. And then we'll reconvene in the new year. So the second Wednesday in January will be the next DoES Salon. And at the moment, we don't know for definite who's going to be speaking. And so my arm twisting is maybe working, but maybe not. We'll see. You'll have to come to the DoES Salons in the future, Jackie, to find out. But with no further ado, I shall leave you with Luke.
Hello. So I want you to just jump in if I've said something you don't understand or I'm missing bits. I'm trying to cram a lot of my thoughts over the last 13, 14 years into some slides, and I hope I get across the answer to this question: can hydrogen fuel cells fight climate change while simultaneously helping local economies thrive and, as a result, improve lives for all? So a bit about my relevant past. I started working in IT back in the 90s as my first job, which set me up pretty well, really. It was when email was sent over dial-up between post offices and kind of making systems work, so it taught me to think of things as components, which has helped me problem solve later on in life, I guess. And then in 2000, working in this company, I was with people who've been working there all their life, really, and a couple of my friends said they were going travelling, did I want to join them? So I ended up going to South America, and there I spoke to a number of people, learnt a number of things, but what really stuck out was I met a Norwegian student who was looking at how cancer levels in Chile had risen due to holes in the ozone layer. And that was my first realisation on how human impact. So that was from industrialisation, acid rain going across, and having an impact in a community had nothing to do with that process that was being done. So I guess it was my first realisation of how we impact the climate. So when I come back, I got a job back in IT, and that was pretty well paid, and as part of that package I got offered a company car, and I started looking into the most ecological choices. I found a book that was Joshua Tickle that was about how to run vehicles or engines on vegetable oil. So I converted a van to run on Greece and drove it to Greece, which actually worked out pretty good. But it was my first kind of experience of trying to make a change, did some research into waste oil that was produced in the local restaurants, local pubs, and it turned out that there was enough waste oil to run the longest bus service in Maidstone. But when I went to speak to anyone really, who was I? I didn't have any education, I wasn't an engineer, so I didn't really entertain the thought. There was a taxi company interested, but because of the way the system worked, you have to, you can either use a chemical to break down the vegetable oil and use it in an engine, or you can heat it up. And the option I was using was heating it up, which only really works if you're running the engine all day long. Taxis turn off their engine, so the oil cools down, whereas on a bus it's running all day, so that would have been good. So that led me to go through a conversation, deciding to go to university. So I took some AS levels in 2007. 2008, when I was studying, climate camp come to Kent, so that was in the King's North. And I got a really good education there on climate change and politics and how groups kind of work together or don't work together, I guess, in other instances. And then I went to university, and in 2012 I graduated with ME in engineering, and in 2014 started a PhD looking at hydrogen production and working around alkaline fuel cells. So 2008, because I was seen as a local activist, I was kind of pushed into these situations. So there's me wearing Gordon Brown's head. And as a result of that, I got to interview this man, James Hansen, who's a climatologist. He's the person who kind of proved that the effects of CO2 and the increase of CO2 and linked that to the changing climate. I think it was a radio interview that I interviewed him, so I got to have a chat with him, but there was a number of things he said. So out of every country on earth, the UK bears the most responsibility for historical CO2 emissions. Kind of when you hear debates about climate change, it's like, well, but what about China, what about America? But because industrialisation started here, we have a big responsibility for our past emissions. The other thing was saying about the safe level of no more than 350 parts per million of CO2 in the atmosphere. It says, a rise of 2 degrees is a recipe for global disaster and not salvation. The last time the Earth was more than 2 degrees warmer than it is now, there was a 25-metre sea level rise. He said in private that 350 parts per million was kind of dragged out of him because people kept on insisting on a number. What figure can we use as a target? And he said he regretted saying that because it should be much lower. And he also said to prevent significant loss of life, we need to be bold and turn the ship around by 2012. So I'm trying to paint a picture of where I was when I graduated and what was in my head. So in 2018, so I was becoming more aware of climate change and learning more as I went. 2018, the IPCC report, which was on 1.5 degrees, finally admitted the primary driver of long-term global warming is carbon dioxide emissions. So the debate was ended. Global temperatures relate to increased cumulative CO2 emissions from human activity. Significant loss of ecosystems and biodiversity, increased human health economic impacts at 1.5 degrees and greater again at 2 degrees. Global warming of 1.5 degrees at between 2030 to 2052. An urgent and wide-scale change is necessary in the energy sector. So, what I should also add really is that last year we hit 1.5. So that prediction even in 2018 was 5 years out. I want to show you this here. This is all pretty miserable stuff, sorry. I think it's important to know the severity of the situation. So this was a presentation by the Tyndall Centre. So it was talking about how much carbon we have left. So allocating areas with how much CO2 it can produce over so many years until for us to be able to meet 2 degree targets and 1.5. So you can see the steepness of the graph. If we were to hit 1.5, and this was done in 2020, it was 2020, I think this was from. So for us to reach, meet the 1.5 by 2040, 2050, we had to be zero carbon. And then if we were to look at 2 degrees, it's still a pretty steep slope, and unfortunately we've not been meeting any of those slopes. So what we've got to do is pretty frightening, really. Zero Carbon Britain have wrote many reports over the years. They've done fantastic work trying to raise this issue with politicians and decision makers, I think since the 90s. 2019 Zero Carbon Report, they say we can't do anything without powering down and powering up there. So the first thing we should be doing is looking at reduction of CO2. So the two that I'm highlighting really that I like is in the houses, so high passive house standards. That means just super insulating homes, meaning that people are more comfortable and spending less on their energy, but also producing less CO2. And then changing how we travel, so more active travel, switch more walking, cycling, use of public transport, and then vehicles more efficient using electric. The good news is we are actually doing some of this, and we are moving towards this, and there is a lot of movement towards active travel. There is a lot of understanding about retrofit. There's still a big skills gap, but we are moving in the right direction slowly. I find looking at a big problem is just too difficult, so I like to break it down into sections, and I think the only thing that I can do right now is focus on, right, okay, Liverpool, this is where I am, what impact can we have here? And if you look at 30% is road transport, 22% is domestic gas. Just by that powering down, you already have quite a significant impact. But the questions are always, who's going to pay for it? Why would energy companies encourage users to spend less money on their product, which is energy? How do landlords cover the costs of retrofit without increasing the rent to be on reasonable levels? Or I have a legal obligation to ensure maximum profits to my shareholders. So it's generally cost. Hopefully we'll discuss and answer some of these questions. So then in 2012 I graduated, and I was, one of my friends called me to say that they had some contacts that they'd put me in contact with. One was with Engineers Without Borders. Another was with a solar farm that was being built down in the southwest, or another person was fuel cells. And I said at the time, I definitely do not want to work with fuel cells, as I believe that the hydrogen economy is being hijacked by the oil and gas industry. And I was concerned that it was going to keep business as usual. So why I didn't want to work in the fuel cell industry is where hydrogen comes from. It comes from oil and gas. It's generally steam reformation or some kind of byproduct of that production. And then research at that time was looking into mixing hydrogen into the gas network. So we were looking at burning it anyway. So even more stupid really, because then you're continuing the same kind of, we can just burn anything. And then there's electrolyzers, so electrolysis where you're splitting water with electricity using renewables for that. The efficiencies of that are not very good. You've got 70% from the electrolysis process, and that's quite optimistic, I think. Then the compression of hydrogen to be able to transport it. And then fuel cell efficiency is 60%, so that's 38% efficient. So why not just use the energy directly or other means of storing energy? So the main issues there was it's created by the oil and gas industry, inefficient use of energy, and then the other thing is it's also, if hydrogen leaks, then it's a greenhouse gas. It can prolong the life of methane in the atmosphere, which is an even more serious greenhouse gas than CO2. But then this is the person who called me up. So this is Nick Abson. He's probably all know some of his work in the music, video or television. He did, everyone loves it, he did Fraggle Rock, so he directed Fraggle Rock and Krypton Factor, if you're that age, or Diana Ross videos and Queen's We Will Rock You. But he also made TV programmes, science programmes, and through that came across fuel cells and got involved in, well, really the bug with alkaline fuel cells, which were being made by a Belgian company who made them for the European Space Agency. He then took that technology and commercialised it through ZTEC, building the first fuel cell powered taxis in the 1990s, fuel cell powered boat, and what else? And a fuel cell powered carousel as well he built. But his experience of ZTEC went bust for a number of reasons. 9/11 was probably what killed it off from his investors pulling out. But he had this dream of making fuel cells cheap. So at the time, they had to get machines to make the fuel cells, and they was very, very expensive. And he decided, well, we should make these so that anyone can make them. And his dream was to create one that could be made by Maasai tribesmen, which I think we have if you can give them a 3D printer. And he's very good at big picture strategy. So he sold me on community waste to energy. So seeing waste as a resource, and I was already that way of thinking anyway through the waste vegetable oil, or the way I was living with picking things off the street and making good use of them. About hydrogen production through gasification, fermentation, where you can create ethanol, or digestion. So briefly, just what them technologies are. A gasifier is good for dry waste, so wood waste or anything that's burning, and gasification is kind of like a controlled burning. If you think of, if you see a fire and you see the flame is the gases burning. So if you see someone toking on a cigarette, then embers glowing, all of the gases are being removed. So it's kind of a good visual way of understanding kind of what's going on. So as you're drawing over gas over your fuel, you're producing hydrogen and carbon monoxide, which are both usable fuels. Fermentation is anything with sugars. So British Sugar, they had huge ethanol plant in Hull, which is from their waste beet product. So it's the waste part of the plant that they couldn't use, and they were one of the world's largest ethanol producers. I think it's shut down because the UK didn't commit to higher blends of ethanol in their fuel. And then digestion seemed to be explained by a cow's stomach. So any kind of organic waste is broken down by bacteria, and the result is methane gas, which can then be converted to hydrogen. So when we talk about waste, there is a technical term for what is waste, substance or object in the categories set out in Annex 1, which the holder discards or intends or is required to discard. But generally waste is anything that someone doesn't want or they can't afford to hold anymore. So in industry, quite often stuff is too expensive to hold on to, so it gets thrown away. What can be powered by waste? So buildings, residential areas, public transport or larger vehicles, or even shipping really. So with alkaline fuel cells, they're suited to larger power applications. So I guess a taxi's at the lower end. You probably really wouldn't look at taxis. We'd be more looking at buses, trains, HGVs, and then power stations. So what I liked about the idea is if you know in a certain area what kind of waste is being generated, how much of that waste you can then collect, so you'll get paid to collect that waste. You know what the amount of hydrogen that's going to produce, and then you know the amount of electricity that's going to produce. And the waste products are water, so it's a reverse reaction of splitting water, so you're creating pure potable water that's at 70 to 90 degrees, so you can use that heat. And all on a smaller scale, so then it encourages the collection of waste and the sorting of waste and job creation. Let's skip over that one. An issue is we don't want to get caught into this trap of using waste as an energy because we don't want to be creating waste because we need the energy. There's a situation in Manchester where they were having to buy in waste to power to meet their power needs or contractual obligations really with the waste to energy plant. We should be preventing waste first and then redistributing it. So making sure that anything's useful gets used and then recycling. And I think by having localised power generation, you have the opportunity where you've got community involvement with the collection and the swapping and the processing. You're more likely to be able to put it to reuse if you're connecting it rather than it all going in a big lorry being shipped miles away to be burnt. There's a big pushback on biofuels, rightly so, because it can be really bad. Drax Power Station is a good example of how terrible things can be and how trees that we need can be cut down and pelletised for burning in an inefficient system. There's also reforestation for palm oil, which I think COP30 is actually trying to address by this protecting rainforests and having richer nations pay for it. I think that's a good thing. But on a smaller scale, I think it can be good. Like we're utilising a resource that can be used locally. So in Brighton, there was a big lemon company, which I think is no longer there, but they were running buses on waste vegetable oil. And I thought that was a good example of how you could use a local waste to provide a local transport system. So biofuels, are they good or bad? Well, it depends. You have first generation where you're growing stuff predominantly to be used as a fuel, and then you have the waste. When I talk about waste to energy, I'm talking about the second generation biofuels. Another benefit is our grid. Our national grid is very old. We have problems with where installations can be. So with renewable energies, there's situations where's best for the renewable energy, the grid just can't cope with it. And it might be that someone wanted to build a wind farm, but the connection isn't there. So how it works at the moment is that person would then have to pay for the upgrade of the grid. So there's having localised waste production that's then producing energy could be put in areas where the grid could cope, or it supplements a base load energy, because again, you know how much energy is being produced 24/7, so that can then be supplemented by the renewables. Fuel cells. So the heart of what brought Nick to this point was that hydrogen availability. It was expensive. I think there's probably as many fueling stations now as there were in the 90s. So he was making hydrogen just to fuel his fuel cells, basically to create the opportunity for using fuel cells. Fuel cells aren't new. It was William Nicholson and Anthony Carlisle in the 1800s. They laid out the way of how water splitting, and William Grove then reversed that to say, okay, how does this work backwards? And then he proved that you could then recombine hydrogen and oxygen to produce electricity. And then Thomas Bacon produced the first practical fuel cell in 1939. That fuel cell went on to be used in the Apollo missions. So there's the first hydrogen fuel cell tractor by Alice Chalmers in 1959. That wasn't sold because the farmers complained it didn't make enough noise to scare off the birds. And then there's the first hydrogen fuel cell van, 1966, which was built by Carl Cordesh. And then he also put fuel cells on his motorbike and rode across America 3 times in '67. So when you talk to people about fuel cells, they seem to think it's this technology of the future, but it's been done, it's known. A lot of research areas is in different types of fuel cells, and it's about kind of small advancements. And some of it's good and practical and useful, but there's I like to compare it to batteries. So you have different types of batteries for different types of situations, and I think an alkaline fuel cell, like alkaline batteries or a lead acid battery, have their place amongst lighter technologies or more power dense technologies. So alkaline fuel cell, I'm not going to go too much into this because I'm going to show you a video in a minute which probably explains it much better. But the difference between a battery and a fuel cell really is that a battery, you're putting energy in, there's a chemical reaction, and that energy is stored as a chemical energy. Whereas a fuel cell, it requires conversion of the fuel almost on the outside. So all the time you're providing fuel, the chemical reaction happens that produces water and electricity and heat. So hopefully this is going to be a really poor quality video.
The most promising alternative to petrol is literally about to hit the streets. A van that runs on clean electricity and can be refueled just like a normal car. In 2 weeks' time, this van will be the first working vehicle in the world to be sold running on fuel cells. Now put very simply, this is the difference from an ordinary car. It's fueled by hydrogen. And this hydrogen, when mixed with the oxygen in the air, runs the electric motor that drives the car through a fuel cell. So what is a fuel cell and how does it work? The chemistry of the fuel cell is based on one of the simplest reactions there is. Take hydrogen and oxygen, and with the help of a catalyst you get water, heat and, crucially, electricity, which drives an electric motor. It's a bit like a battery, but while a battery is always running down, the beauty of the fuel cell is that its fuel, hydrogen, can be filled up quickly, just like petrol. Now for the best bit. No more air pollution. The only waste coming out of the car's exhaust is water vapor. And this is a stack of fuel cells bonded together. This is what one of them looks like. And what actually happens is the hydrogen comes in here, passes through this membrane, and acts with the oxygen on the other side to pass the electric current out through this wire net. So will fuel cells take off? This is the very latest design in London taxis, still using stereo diesel. Not for much longer, though. Businessman Nicholas Abst is about to introduce fuel cells to this old British paper. What's so special about this taxi cab?
By June, July, it will be running on a pollution-free silent hydrogen-powered fuel cell. And not only that, the public will be able to ride in them. This cab will be the first of 100.
So there was Nick, and I was wrong. Tomorrow's World didn't explain it very well because you don't want the hydrogen and the oxygen to mix because then you don't get anything. You but yeah, that's kind of roughly right. So coming back to this system, there's also other benefits. So you've got the waste collection, so the local economy you're creating from that, and then you've got the local production of energy and heat and water. But there's also soil enhancer and alkaline fuel cells. In academic literature, they say that for many years they said that alkaline fuel cells couldn't be used on Earth, and it's because it was said that CO2 poisoned the electrodes. What actually happens is CO2 reacts with the electrolyte. It creates crystals that blocks the pores. That can be reversed, but what was used on those fuel cells in that taxi in that video was just a CO2 scrubber. So removing CO2 from the atmosphere, they are early CO2 capture devices. So what we're exploring more now is looking at using, instead of building these huge fans that are blowing air through into adsorbent to just capture the CO2 and then sell that, and they're getting paid to do that, why aren't we just installing fuel cells that are producing electricity and heat and using that as a CO2 capture device as well? So it's kind of a big industry, hydrogen and CO2 at the moment. And unfortunately what seems to happen is a lot of money goes to these fancy technological fixes. Some of them are, I understand, necessary. And if we go back to the beginning of what we're facing, I understand why some of these decisions are being made. But, you know, like it's pretty, or I'm pretty certain that we need to remove a lot of CO2 out in the atmosphere. should we be paying the oil and gas industry to do that? I don't think so. But there are other more local opportunities. I mean, there's a CO2 market, which happy to see that Ecotricity have said that they're not going to participate in the international CO2 market. They said they're going to spend their money more locally on CO2 capture projects or CO2 positive projects, which could widen out the playing field. There's a lot of synthetic fuels can be created from CO2. You can create plastics. You can create all kinds of different things from CO2. But also, if there's growing foods in greenhouses, they'll pump CO2 to accelerate growth. So on the one hand, we're trying to remove CO2 from the atmosphere, and on the other hand, we're pumping CO2 into these huge greenhouses. So just to give you an idea of the capabilities of these systems, these are kind of ballpark numbers, but from looking at Liverpool, Toxteth, we had a site where we were looking at local collection. The UK produces 7 million tonnes of food waste per year, and that's approximately 8.4 terawatt hours of energy. But we're looking at Merseyside and Horton. They produce between 132 to 162,000 tonnes of food, which was 158 to 194 gigawatt hours per year. Bringing that down more local to the Princes Park ward, that was between 1.1 and 1.3 gigawatt hours per year. And then just looking at two specific supermarkets, if anyone knows Toxteth, you've got the TAC Superstore. It's not called TAC Superstore anymore, it's the one on the corner. And then you've got the International Superstore. So we looked at their waste, their food waste, and from that it would produce about 61 kilowatt hours per year. So it's not huge numbers, but I think it makes a dent. So going back to those points that people raise, or the questions that they raise about who's going to pay for it, how are we going to do it, for me it keeps coming back to local authority ownership, really, which we are starting to do. I think Manchester's done it with the buses. I think Steve Robbins is going down that path with the trains and trying to with the buses. So every time you buy a ticket, that money goes back into local council. What's previously happened across the UK is you buy a ticket on a train or you buy a ticket on a bus, it goes to a private company who's usually owned by another country's government, and then it subsidises their own national transport system. We've got ESCOs, where energy service contracts are anyone where you buy and sell electricity. In the US, a lot of that's done by local ownership, so local government will own a part of that. Starting to see it happen in Belgium and Germany, and actually there is a movement towards that in the UK also. So I know Nottingham did it with their Robin Hood, yeah. It's energy service contracts. I can't remember what it is actually, but basically it's like Scottish Power or the people who buy and sell electricity. So I think the current rule is you have to have £1 million to start up as an ESCO, and it's basically enables you to buy energy off any producer and sell it to a user. So I think they did the Liverpool Lecky, which was kind of a halfway house attempt at doing this, where they could then buy from the energy producers and then sell. But what it enables in Nottingham is, if there's any kind of community energy project, they could sell to the ESCO. So if you knew someone who owned a load of houses, they could put a load of solar panels on that roof, sell that to the ESCO, and then that could get sold locally. At the moment, I mean, again, there's change, so you can start to sell energy back to the grid, but you can't sell it to your neighbour. If there was a Liverpool ESCO, then you could. So you could say, well, I'm producing this amount of energy that I'm not really using in a day. This person works from home in a day. I'll sell it to them for less than what they're paying, and I'll get money back. So it's enabling those kind of opportunities. For what I'm trying to do, it needs that, because if we're creating energy locally, having local authority involvement, one, it brings the ownership of our waste back to us, and then we can use that resource to produce electricity. But it also enables the growth of these projects. So if they wanted to put a wind turbine somewhere, they could use money generated from the sale of electricity. It's also another way you can raise investment. So they call it futures. So if you know someone's going to buy electricity off you for 5 years for a set price, that enables the person who owns that contract to go out and raise money and give them 1 penny or 2 pennies per kilowatt hour. So it's a way of funding forward projects, really. So it's another leverage arm. And buildings like co-ops or social housing as in certain areas has actually used this model where they install retrofit or they'll install some kind of energy saving system, whether it's insulation, and they'll raise the rent by the savings of the electricity bill savings. So the tenant doesn't see an increase in price or drop in price really for the first bit, but it means they get a warmer home, and then eventually that gets paid off, and then it becomes cheaper for everyone. And then, the valorisation of waste. And that's it. Don't know how long that took. Oh, that's longer than I thought. So anyone have any questions or, yeah?
What's an up-to-date situation on what's going on at the moment?
Yeah. Well, so.
I don't know if people know about that.
Oh yeah, so you might not know that January this year, my lab was set fire to. Someone poured petrol all over it, and in there was a kilowatt fuel cell stack, 3 control systems, all of the materials to build more fuel cells, the jigs to make them. Yeah, kind of. We were close to being able to teach people how to make them, really. And, well, furthermore, the site I was on, there's been a lot of slanderous accusations, really, from council members and MPs about what I was doing on the site. So as a result, I'm no longer on that site.
But other people unturned their own, actually. Other people have had to move off the site.
Other people have had to move off, yeah, as a result, yeah. So where I'm at really is my PhD finishes in end of March, and then so I'm working just trying to get that, and then between March and April, I should say from the fire I did a crowdfunder, so that money's being used to build another kilowatt fuel cell with a control system that I'll build in probably April, May, to put onto an airport tug to show people, hopefully May. Yeah, that's the current plan. Yeah, well, hopefully I'll come back with a tug and do another talk. Anyone else? Yeah.
What's the relative efficiencies of those fuel cells? Are they getting better than they were?
So, I mean, an alkaline fuel cell will always be about 70%. Proton exchange membrane will always be around 60%. So they're already pretty much at their limits of efficiency. But because the waste is heat, the idea, and with an alkaline fuel cell, it's a liquid electrolyte, so you can make that heat useful. So 70% is just the electrical efficiency. When you look at power stations, they'll use combined heat and power, so they'll include the heat as a part of that equation of increased efficiency, which is why you can have a heat pump that's got 140% efficient, which, yeah, so as a system, I don't know what it could be. And it's the same with the waste to energy stuff. So with a gasifier, they operate about 1,000 degrees, and then the conversion of methane to hydrogen, you need a reformer that's about 800 degrees, and then 400 degrees for the second part of that process. So I've been looking at whether you can use the gasifier's heat to drive the reaction from the steam reformer. And then again, so you've got anaerobic digestion is a wet waste, and at the end of it, you've still got a wet waste which you want to dry. So the post and pre processes for that, it's looking at how you can use some of that waste heat to then do some of the other processes. So on a smaller scale, I think you can increase efficiencies at each step. What we tend to do is build huge power stations because they're looking at economies of scale rather than, like system thinking really. I don't know actual numbers. Yeah.
But it is again, a combined system.
Yeah.
That's going to be the hard one. Again, the individual components work.
Yeah, well, yes and no. I mean, gasification's been around. Well, town gas in London was gasification, so it's well understood, and anaerobic digestion is also well understood. The problem is again, they're all built like, so the gasifiers that have been built or going to be built and are all like massive scale, and they all have the same problem of tar. So you get tar build up. So what then happens is that we spend loads of money on researching how to remove that tar. So then there's all these clever ways of reducing tar, whereas on a small system you could have two, and you shut one down, clean it, and then keep the other one operating. So I don't think the joining up. I think there is a lot of research to be done and a lot of work to be done on joining them up, but I think that's only going to improve it. I think even if you had clunky system installed now, it'd be fairly competitive with what exists. I mean, there's gasifiers that run on, basically they make gas, then they dry the gas and put it through an internal combustion engine. So
Well, historically, it was town gas.
town gas, yeah.
You used to get town gas, so
Yeah,
every local town had a gasifier.
yeah,
And was probably massive CO2 sources.
yeah,
Because they use coal
yeah,
as the say, the gasifier to make the local gas,
yeah,
which is just making coal into methane.
yeah,
So it's amazing how many different places. I worked at a BT office in Manchester, which was built on an old gasworks, and they had to dig the car park up to remove the tar that was buried in the massive pit in the
wow,
car park. So there's still a lot of that industrial legacy around
yeah,
in Victorian towns and stuff like that, which a lot of people have forgotten about. But possibly we need to go full circle and come back round to that. We have more local plants, like on the industrial estates, which is producing hydrogen and CHP for local housing estates.
exactly, yeah,
But most of the housing estates that are being built at the moment are for electricity and gas, and
Yeah.
not for CHP.
no,
Is
No.
it more Holland and places like that which are more
yeah,
use
well,
CHP?
I mean, the university has its own energy production, and all the buildings are heated from CHP. So there's, if you know, combined heat and power. Sorry, yeah. So like, it's basically a multi-fuel power station they have. So university has its own ESCO really, so it creates its own power. And if you walk around University of Liverpool's site in the winter, you'll notice that there's no ice because there's hot pipes underneath all the ground. So not only does it prevent you having to go around and sort all the roads, you're actually transporting your heat from building to building.
I mean, the Knowledge Quarter has a heat network
Yeah.
as well, so the buildings being built, like hemisphere and stuff, will plumb into the Knowledge Quarter district heat system. And there's another one down at the docks, the waters. So there are some of those in the system.
Yeah.
So on the internet, Pat Link would like to know if we're going to have hydrogen fuel cells, and then and Darren wants you to repeat the questions from the audience because it's hard
Oh, right.
online to
Yeah.
hear what's been asked,
Okay.
which is very good point.
Yeah.
But yeah, Pat would like to know if we're going to have hydrogen fuel cells, and then what will be the way to power vehicles in the future as fully electric still uses a battery that won't last forever.
Yeah. Well, I do think we're going to have fuel cells. Yeah. I think we're also going to have batteries. There are fuel cell powered vehicles which have not use batteries, which seems bonkers to me. So I think you would always use a battery and a fuel cell combined, and then you'd keep the battery in its, prevent it from going into its deep cycle, so you're prolonging the life of that battery. I don't think that's going to be passenger vehicles. Personally, I think we should be having a public transport system that's so amazing that you don't really need to drive anywhere in a car unless you're transporting goods, and that's going to be a different. But even that, you can do bikes. If you go to Denmark or Netherlands, everyone's pushing a bike around for their shopping, or I mean, even IKEA do it, where you can go to IKEA and you can get a cargo bike to take your shopping home. Fuel cells for power stations, I think so. I mean, fuel cells have been used in submarines by the Russians for a long time. Fuel cells have been used in space. I don't know what the main barrier to fuel cells is hydrogen. I don't think the problem is, do fuel cells work? Yes, they work. Are they affordable? Some are, I guess. But all the time, the cost of hydrogen is really high and the availability of hydrogen doesn't exist. It's a bit like the charging network for electric cars. Until there's a good electric charging network, there's not going to be enough electric cars, and all the time there's no hydrogen supply, there's not going to be enough fuel cells. So it's kind of why Nick started looking at production of hydrogen from waste, was to create that cheap fuel. Where it works best is in a place where there's no energy network or waste system. So if you've got somewhere where there's intermittent power, they're producing waste because they're there. Anaerobic digestion can run on sewage waste. So from that, you've got a point of generating heat and electricity and soil ameliorate, so you can improve the soil to be able to grow stuff. So that's where I see these fuel cells being used, or that's how I see it in the future anyway. Yeah.
You mentioned earlier that 70% is about the efficiency of the cells, and the rest will be heat, and then you can use a combined system or make use of the heat. But I'm curious, kind of what, I guess, what's the temperature of the heat that usually comes out of it? Like, is it high enough to be useful, or is it sort of just like?
I mean, it's an exothermic reaction, so it generates heat. Oh yeah, sorry. Oh God, yeah. Can you say it again?
I guess what's the temperature usually of the heat that comes out, and is it dependent on the fuel cell?
Yeah. So yeah, the question was talking about the efficiency of the fuel cell being 70% and using heat. And the question was, what is the temperature of that heat, and is it usable? So different fuel cells operate at different temperatures. You get low temperature, which is up to 120, 130 degrees. So the popular fuel cells, in terms of what's being pushed both in research and probably the main ones in industry, are proton exchange membrane fuel cells. And you get both low and medium temperature. Capturing the water in that is difficult, and capturing the heat is therefore through the air. So the efficiency of capturing that heat is probably slightly lower than what it would be on an alkaline fuel cell, but you're still looking at temperature of like 70, 80, 90 degrees. An alkaline fuel cell, the one we're working with, operates at about 90 degrees, and that's just because we're using plastics. So it's the limit is what we're using there. We could use different materials and increase the temperature to probably 130, 140, but because it's a liquid electrolyte and it's easier to remove the water, then you can use the hot potable water coming out at 80, 90 degrees. Yeah, so you can either remove the energy of that or use that for heating or even washing. But because it's pure water, you probably need to add some stuff in it to make it clean, some minerals in it. But yeah, for heating, I think you could definitely, for, I mean, when we're talking about electric vehicles, if anyone's driven an electric vehicle in the winter, but as soon as you have the fan on and the lights on, the range goes down pretty drastically. Whereas if you had a fuel cell in it that's pumping out heat, then at least you can heat the cab or heat the vehicle with the waste heat. So that small advantage of not draining the battery, yeah, it's an example of being usable. Anyone else? Yeah.
How much hydrogen does it use to produce a kilowatt of power?
It's meter cubed. Oh, question. How much hydrogen does it take to use to produce about a kilowatt of energy? It depends on the fuel cell, but yeah, as a ballpark, it's meter cubed, normal cubic meter of hydrogen, which yeah, quite a lot, I guess, in terms of volume, but yeah, this I mean, this is why with vehicles they compress hydrogen, because you need quite a lot of hydrogen for running a vehicle. So, and that's one of the issues with using hydrogen is that energy loss from compression. So using it in stationary applications kind of bypasses that. Because if you're producing the gas, converting the gas and then using it, you're building your fuel cell system to your kind of available waste. And it bypasses that energy loss problem really.
So would it make more sense to have a fuel cell in your house that also heated your house and then just charged your car?
I think it's a district system, yeah. Maybe at the end of a street, so in 10 houses, 15 houses, 20 houses, or on industrial estates. It's kind of what we're working towards is containerized systems that would be about 50 kilowatts. So what was that? I think it's about 400 litres of food waste. So if you think of the big bins, I think they're like 250 litres. You know, the big double bins you see outside of supermarkets. Yeah.
So which form of waste produces the highest amount of energy?
Yeah. Oh yeah. What type of waste produces the most amount of hydrogen? I mean, it depends on the process you're using, but this is, you know, food waste is like 80% water. So there's a lot of hydrogen in water. So it depends on if you can capture that water and use that as a part of the process in steam reformation, then you can increase the hydrogen output from that. But on the other hand, if you've got dry waste, then you can use gasification, which is going to take the water out of the air. It's difficult. I don't know. Depends, I think. Yeah.
Another question from the internet. Pat again would like to know if was HS2 drinking the water from hydrogen really safe or a stunt? As they used hydrogen to run machines in the buildings of Birmingham. I guess, is the water that comes out of your fuel cells safe to drink?
Is the water that comes out of our fuel cells safe to drink? Yes.
Distilled water.
It's distilled water, yeah. So, or deionized water. Yeah. Is pure water.
What are the expensive parts of fuel cell, like the catalyst and stuff like that? Is it the catalyst?
The catalyst is an expensive part. So again, that depends on the types of fuel cells. So some fuel cells have to use or rely more on platinum. Thomas Bacon's fuel cell was just nickel as the catalyst, which is much cheaper. That was high pressure and using pure oxygen and hydrogen. But alkaline fuel cells do present more opportunities with different catalysts. So you use silver and gold, but yeah, still expensive. But the quantities required are quite small. So you can get away with 5–10% platinum loading, whereas a proton exchange membrane is probably 20–25%. And then there's also whether you can reuse some of that. So the fuel cells that we're using, they're been designed to be recoverable, so you should be able to recover the platinum and the nickel, whereas a proton exchange membrane is it's in a polymer, so getting the polymer off from breaking it down and recovering it's still doable, I imagine, but yeah, energy intensive, a bit more tricky. I guess it's like lithium-ion batteries, they're now able to reform those and recover those, so it's all possible, whether it makes economic sense. But, if you're throwing it away, then that's a different cost to if you can recover it and reuse it. So that's what looking at with these. Well, that's what Nick's designed in these, is that it is recoverable and reusable. So the idea would be that you'd be charging for the electricity and then supplying the fuel cells. So as they get improvements, they get upgraded, and then you bring the old ones back and recover the materials and rebuild them. Yeah.
Are there
Hiya.
any more questions?
Yeah.
Sorry, no, that's good.
I'm an environment sciences student, and I was recently reading a little bit more on circular economy. So I'm just out of curiosity, what is your take in general on how Liverpool is pursuing their agenda of circular economy? Is it supported at all by the public and by the local authorities, the transition?
So was that, what do I think Liverpool's?
Yeah, like a little advocate for circular economy, because I know there's a couple of cities across the UK, like Glasgow, for example,
Yeah.
do a lot in the shift to circular economy.
Yeah.
Do you seem to recognise any shift towards that in Liverpool?
Yeah. So the question I think is, what do I see in Liverpool in housing engagement or a movement towards the circular economy? I've been to a lot of talks by people who have talked about the circular economy for years in Liverpool. It definitely gets mentioned a lot, and there's been a few people I respect who have wrote books on it in Liverpool. And there's people here doing work on it, actually. Tom is doing work on a kind of circular economy. So I think there's definitely a movement towards it. I think there were natural circular economies which have probably gone. I was talking about the other day how an industrial estate, people would have used to gone around the industrial estate to buy parts off of other people that existed, whereas now they'll go on the internet and order it and it will get delivered. So I think some of that is being lost by the nature of what we do. But I mean, I was in conversation. Trouble is, I've been doing this for too long and it's not happened quick enough. So the people that I was speaking to in local authority have now gone. They were very into the idea of circular economy and saw, especially around waste, how it's necessary. And I don't think we can, so at the moment economics are kind of looked pretty narrow-minded. So when we look at comparing power generation, it's not looking at the same kind of boundary conditions of that. And I think we need to look at a more circular approach to enable these smaller community energy projects, looking at wider benefits, and the same for really active travel as well. People are starting to look at health benefits. So NHS now is providing funding for cycling initiatives or active travel initiatives. So I think there's definitely more movement towards it. I'm hopeful that it's going to keep going that way, yeah.
Cool.
Okay.
Speak now or go on.
So, thanks for that, Luke. That was awesome. And next time you come back, you're going to bring a fuel cell and we'll power the projector off it.
It'll be outside on the tug, yeah.
Excellent, great, that was good. Yeah. Thank you all for coming. Thank you to the internet for watching and asking questions. I hope you can hear me.
Oh yeah, sorry.
Sorry. Thank you, internet. Yeah, as I say, the next one will be in the second Wednesday in January, and we've got another volunteer for a talk in the comments of the live stream, so that was good. So I will let you know if you sign up, join the group, the DoES Salon group on events.doesliverpool.com, then hopefully you'll find out when the next event gets announced. And yeah, I think there's still a few beers left, and we only want to have a chat for longer. But yeah, thank you very much, Luke.
Okay, thank you.